Hello everybody, today we'll be going through the video portion of our project number 2, the logic gates. I'm going to start off with the not logic gate, but before I do show you what I got, we got our 9-volt battery with power cord to do it. We got our circuit board, which has our ground negative, our positive to 5-volt. We're going to be using for today, I already got set up to begin with the knot, but just for time purposes, but we're going to be using 2 transistors throughout the process. One 1 kilo ohm resistor and 1 LED light. We're going to be using 3 jumper cables, but the green one and the blue one I chose to use as switches. It just makes the color contrast a lot easier and to distinguish. And then the third jumper we'll be using to connect everything together. All right, so the first one we're going to do is our not logic gate. Here we have the symbol. It's your triangle with an input and an output. But here's the thing, the red represents the current flow path. So we're going to go from our voltage source through our resistor to a switch, which completes the circuit and does not allow the light to turn on, the LED light, because there's no power being driven. So if it's not this way, this circuit, the circuit goes from the voltage source to resistor to the light because the switch is off and back. So here's the flow path. And according to our logic truth table, we should be able to recreate this right now in person. All right, let's give it a shot. All right, so here we have our 1 kilo ohm, our LED light, and our first transistor. So we'll set up a little jumper cable so we can close the circuit as needed. We'll put it next to the emitter portion of our transistor and back to ground, just so that we can close the circuit if we need to. Next, we will add in the green jumper cable as our switch. And see if I get it right in there. All right, so this switch represents the switch in the off position, which means once we add our power source, that LED should turn on. So let's add in our negative first. Add in a power source. We do have power. This positive representing our power, once I turn it on, should turn on the LED. And it does. So, path of current is, since the switch is off, is going through the LED light and back around. Now, once I put this switch into the on position, which basically I just put it into the base from the collector, our LED should turn off. And it is. And our switch is off, so our LED turns on. And our switch is on, so the LED turns off. And that completes the not logic gate. All right, let me just disconnect the power here. And get rid of our jumpers. And we'll set up for the AND logic gate. All right, next we'll do AND. As you can see from the symbol, has an A and B input to 1 out. Red indicates the current to flow path. So for voltage source, according to our truth table, if both transistors that are in series are switched off, we will have no light emitted. If one of our switches is on, the other one's off, no light. Another switch is on, another one's off, no light. And both switches on, we should get light. So 3 different ways the light should not turn on, only one they should, when it is completely in series, completing the circuit. All right, let's give it a shot. All right, so We're gonna need 2 transistors for this portion. Let's say right about there. And then we're going to be connecting these in series. Let's go with our series jumper cable. So for that, start on this end. We'll go to the emitter side of our first transistor and then the collector side to our second transistor. That's just so we can help keep everything in series. All right, now let's begin the switches. So this would be the switch for the second transistor. We'll leave it in the off position. This should be the switch for first transistor. So my fingers are just a little too big. And we'll just leave it in the off position as well. And then our light, our LED light, long end on the breadboard, short end on the ground or the negative. Let's do it just like that. All right, so we built the circuit. Let's plug it in, see what we need to do. Let's add in our ground first. And then we'll walk through the truth table. Make sure we did it right. All right, we're in there. Okay, so at the moment we got everything set up. Both switches in the off position. Let's make sure they're in there. As soon as we plug in this power source, we should see light to our circuit board with no light turned on because the circuit is not, the series circuit is not complete with the 2 off positions. So we do have power. All right, so this shows no light on. Let's try one circuit or one get it in there. One switch on. There we go. Okay, so truth table is holding true. We had no switches on, no light. One switch on, one switch off, no light. So might be easier just to see if we can get. And now we got 2 switches on. All right, I might have done something wrong. 2 switches on should be emitting. So the circuit should be closed. Let's see what I did wrong. Everything seems to be in, maybe a little loose. And I believe the LED. Oh, there we go. I was in the wrong position. All right. So truth table was holding true. We had no switches turned on. Light was off. One switch on, one switch off. Light was off. We got both switches on. Light is on. As soon as we disconnect this one switch over here at the base, which would indicate an off switch and an on switch, our LED should be off. And it holds true. Truth table is holding true. All right, let me disconnect this and we'll move on to our OR logic gate. Disconnect power. All right. Leave this switch there. Let's go ahead and take out this switch. All right. So for our OR logic gate, our symbol also has 2 inputs, but an A plus a B. So, A plus B, but it's the OR. So what does that mean? At our truth table, if we have no switches turned on, no light. If we have one switch off or one switch on, it is on. If we have another switch on, and one off, will still be on. And if we have both switches on, it'll be on. So 3 ways the light should turn on because the OR, and 1 way it should not turn on. And the current flow will go from the voltage source up to one light, or through one transmitter with the one switch on, one switch off. Light should be on. Once again, no switches on, no light. Both switches on, light. But if one or the other is on, we should still get light. And then the other current flow path will be the voltage source to the resistor to the on switch. Even though the other switch is off, we should still get light. So these two represent the middle ones, but also demonstrate the completely on, completely off as well switches. All right, let's give it a shot. All right, so we're gonna have to switch this up to let's see, let's move this one up to the middle. All right, and then we have our jumper cable right there in the middle. So we'll have one switch. Let's move this switch so we can get the current flow path. All right, so this switch, this green jumper cable will represent our switch. I'm gonna leave it in the off position at the moment. This blue jumper cable is gonna represent our second switch, and I'll leave this in the off position as well. All right, so if I did everything right, let's put in the ground for the negative, and we'll do our red for the positive. If I did everything right, the moment we get power to our circuit board, with both switches off, no light should be on. All right, we're off to a good start. Okay, so let's turn on one switch, and our LED should turn on because it's OR. If I can get it in there. I think the best way to demonstrate this is right. There we go. Okay, so our LED's on, both switches are on. So, or if one is on or the other is on. And let's see, they should both be on. Or let's see, the current flow path is going down to the middle. And I think I had this one in the wrong position. I think I did. Going towards the resistor. We got them in parallel. Pretty sure something very simple I'm doing wrong. Let's see. That to that. Our power goes up, goes to this to the resistor, to the jumper cable, to here, next to it. Should be at the base and the collector. Then emitter to the light. And we're on or off. That's that completes our ore portion. All right, little struggle there, but we got it. Everything's in, on or off. All right, thank you everybody.